The rest of them, we'll have to ask them to... Oh, Charmaine is here. Welcome for you to join us, Charmaine. Just in time for me to start class. All right, guys, everyone pay attention now. Today, we're going to move on to a new chapter. We're basically going to go through the wave physics, guys. In this chapter here, first and foremost, you're going to learn and label each and every part of a transverse wave. You'll learn to understand that what's the amplitude responsible for, what is a wavelength, how do we define a period, how we're going to find the frequency and formula. Then we're also going to learn about a longitudinal wave as well. And then depending on whether we have more time or not, we'll probably move on from there onwards. Okay, so everyone that is here today, I'm pretty sure you know this by now, but in your syllabus, there are mainly two types of wave. Number one is something we call a transverse wave. It is what we call a transverse wave. And then number two is basically a longitudinal wave, a longitudinal wave that has compressions and refractions here. Okay, this is a longitudinal wave here. Okay, now in your IGCSEs, of course, the most important thing in terms of the wave is to first be able to label it first. I think some of you guys might have learned this in your year 9. Some of you guys may have not, but it's fine. Let's go through the labeling process all together. Imagine today there is an equilibrium position that is somewhere around here. There's an equilibrium position, or otherwise just known as an x-axis for those who are uncertain. Let's say there's an x-axis here. From the equilibrium to the maximum point here, this point is something we call the peak, or otherwise known as the crest. This is the peak or the crest is essentially the highest point of the wave. And of course, this bottom part here is something we call the trough. Don't copy anything down first, guys. All of this will be in your notes, so just please pay attention, guys. Okay, the lowest part of the wave is something we call the trough. Okay, the trough is essentially just the lowest part of the wave. Nothing much to explain there. The third thing that you need to know is basically the amplitude, guys. The amplitude, by definition, is the maximum displacement from the equilibrium position, meaning to say from the equilibrium to the peak is considered as an amplitude. From the equilibrium to the trough is considered an amplitude as well. And usually amplitude is responsible for the loudness of the sound, guys. Basically, if let's say, for example, I have a sound that is a louder amplitude, right? What's going to happen is the wave will have a higher amplitude that looks something like this instead. Okay, compare the red color wave compared to the blue color wave. The blue color wave is said to be of a louder sound simply because it has a greater amplitude here, guys. From here, the first thing you must understand is you must associate that amplitude is directly related to the loudness of the sound. The higher the amplitude, the louder the sound. Okay, so remember, guys, amplitude is associated with the loudness of the sound, yeah, guys. And finally, the last thing that you need to be able to label in a transverse wave is essentially the wavelength. Now, by definition, a wavelength is as soon as it completes one oscillation or as soon as it starts repeating itself. Meaning to say, if, let's say, for example, I say that this is the starting point, for it to repeat itself, it will go something like up, 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 down, 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 up, 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 repeat, right? Then this here is considered as one wavelength. Alternatively, if you do not start from the equilibrium position, let's say you want to start from the peak, right? Then it's the same concept also. You have to go as though it repeats itself. Oh, I just noticed that there's some background music at the back. Has it been... Have you guys heard the background music all this while I was talking? Or did my voice mask the background music already? Could anyone hear the background music just now, by the way? Absolutely zero response, just the way I like it. All right. Oh, no. Oh, great. Yeah, it was kind of loud, but I'm glad to know it wasn't there. But anyways, back to this, guys. Like I was saying, it's either equilibrium to the equilibrium position, or it could be either the peak to the peak, meaning to say here to here is considered one wavelength as well. The same goes for the trial to the trial, because if let's say you start from here, here to here will be considered as one wavelength as well. And the symbol, guys, for wavelength is this thing here. We call it lambda, right? But it kind of relates to the Chinese letter, the root, for those who are not banana here, right? Assuming all of you guys are Chinese and not banana, right? The root is basically the exact same symbol. You know, like in Chinese, there's root, right? I mean, anyone here banana don't know what I'm talking about. But anyways, it's the exact same symbol. Okay, it is pronounced as lambda here. The symbol lambda represents one wavelength, guys. It's representing one wavelength. Okay. So before I proceed on from here, anyone's got any questions with regards to the transverse wave? You don't have to copy this down, by the way. I'll show you what you need to copy down later on. Okay, yeah, if you have no questions, then moving on to a longitudinal wave. Guys, in terms of your syllabus, guys, longitudinal waves are basically only sound waves, guys, meaning to say everything else in the world, as long as it is a wave, is supposed to be a transverse wave. Guys, you have to understand that in your syllabus, the only form of longitudinal wave is going to be sound wave, which you'll see a lot in your paper too. Pay extra attention to this. In terms of a longitudinal wave, very simple. There's only two main parts here. It's either going to be this part where the molecules are close together, or it is going to be this part where the molecules are far apart. Okay. In terms of the molecules being close together, it is something we call the compression. It is basically a region where the pressures are relatively higher. That's why the molecules are closer together. Whereas this part here is basically what we call rarefaction. Rarefaction. Okay, rarefaction is essentially the exact opposite of a compression, right? It is basically a region where pressure is low. That's why the molecules are further apart. If you kind of envision how the sound is traveling, right? I mean, if let's imagine you are here with me today, the reason why sound is traveling is because when I talk, the energy vibrates this particle, and this energy vibrates the other particle, and it keeps vibrating on. Today, when it starts vibrating, right, it kind of compresses the air particle as well. When it is being compressed, right, what happens is it will form a compression, and then some of the part that is being compressed and being pushed away, right, and being pushed away, this is essentially just the rarefaction part. That's why compression, pressure is higher, the molecules are closer together. Rarefaction, the pressure is lower, that's why the molecules are further apart. Occasionally, in your paper 4, in IGCSEs, they'll ask you to define what a compression is, or they'll ask you to define what a rarefaction is. You only need to mention it in terms of the pressure. So it's going to be either high pressure, molecules close together, or low pressure, the molecules are further apart. Okay, and then it will be the same in terms of the definition of wavelength as well. A lot of students, they have this misconception, guys. They think that here to here is actually considered one wavelength because it's the full wave, right? This is what they think. But if you think back about what I've said, guys, I keep saying that a wavelength is as soon as it starts repeating itself, meaning to say, if let's say right today I start from the compression, as soon as it starts repeating itself is the other compression, right? Meaning to say, in order to really say one wavelength, it is either going to be compression to compression. This is considered one wavelength, or it is going to be rarefaction to the other rarefaction as well. This is considered to be the other wavelength. Okay, it'll be the same for transverse wave and longitudinal wave, either peak to peak or crest to crest or equilibrium to equilibrium, either compression to compression or rarefaction to rarefaction. Okay. Anyone's got any questions from this part here that they would like to clarify? Anyone's uncertain with this? Yeah, if you have no questions, then let's see what do you have to actually copy. Guys, copy this down. Let's go through some statements first, guys. If you look at the first statement here, wave by definition is a transference of energy through a space or object, but it does not move the particle in it. You'll see that I conveniently added a small little diagram here. Basically what's going to happen is this guy is shouting on his side, and then it will actually vibrate the air particles. The energy will vibrate the door particle, the solid particles from the door, and it will vibrate the air particles here. And this guy is able to hear the sound. You'll notice that regardless of however much this guy shouts, right, the door itself does not move, guys, meaning to say sound energy only passes on the energy. It does not move any particle. So if you think about it, sometimes, in some kung fu movies, there's this skill, right, called the lion's roar, right? This lion's roar, this guy, then they start shouting, and a lot of stuff are flying around the room, right? Those are all fake one, because why? It's physically impossible. Sound energy does not move the particle, guys. Sound energy does not move the particle, so there's no such thing as the lion's roar, sadly, right? Nothing is actually going to move. Okay, so first statement here is a transference of energy through space or object. It does not move the particle in it. Very, very important. Okay, energy moving from one particle of the door to the other, but the door itself has not moved. None of the particles have changed position. This is the first definition of a wave, right? And at the bottom here, it is essentially a more beautifully drawn diagram of what you should be drawing right now. Okay, you have the crest, you have the trough, you have the amplitude, you have the wavelength, and you have the equilibrium position. You can ignore this, guys. You can ignore this because this is something that we'll add on later on, guys. So just ignore this for now, ignore this for now, ignore it. But everything else, copy down right now. I'll give you guys like probably 3 to 4 minutes to copy everything down. Let's do it real quick right now. And when you're done, just give me an indication that you're done. Okay, everyone done? Anyone not done copying it? Everyone done, huh? Okay, then let's move on to some theory, guys. All right. If you look at this first statement here, right, this is basically the theory of amplitude, which is, everything I mentioned already. By definition, amplitude is the maximum displacement from the equilibrium position. It is either going to be the height of the crest or the depth of the trough measured from the rest position. Here to here is one equilibrium, here to here is another equilibrium. Right, basically the maximum displacement, right? It tells you about the loudness of a sound, right? It's of a, not of a sound, right? And it is definitely measured in meters. Now, some of you guys may ask me this, you may have this in your thought, right? You'll be saying like, hey, didn't you just say that longitudinal waves are supposed to be sound waves? Then how can a transverse wave's amplitude represent the loudness of the sound? And if you think about it, that is definitely true. By definition, sound waves are definitely longitudinal waves. So how can we measure the loudness of a sound with the amplitude? It is basically the conversion of sound energy to electrical energy, guys. If you've ever been to a karaoke joint, right? Even in fact, right now, if you were to look at the microphone blinking on my Zoom, this basically indicates how much sound is there. Today, if let's say I shout into the microphone, I'm like, shout into the microphone, right? What's going to happen is, right, the microphone will convert my sound energy into electrical energy, and that electrical signal, right, will travel all the way through the World Wide Web, and that electrical signal will travel to your speaker, where your speaker converts the electrical sound back into electrical signal back into sound, right? So whenever we talk about these transverse waves amplitude, this transverse wave is already a representation of a digital version of the sound already. Of course, if you think about it in terms of your karaoke, right, if something like shout at it, the level goes from green to orange all the way to red, right? That indicates how loud it is, right? That is also a form that converts sound energy to electrical signals, right? So whenever you think back about transverse waves amplitude, guys, you have to understand that this transverse wave is supposed to be the digital representation of the sound wave, guys. It is not a sound. So, and by right, longitudinal waves are sound. Transverse wave, the amplitude only represents the sound in digital format, guys. Very, very important. Okay. Anyone not sure with what I mentioned just now? Anyone like confused on whatever I've mentioned just now? It's very important. You need to know this, guys. The amplitude is just a representation only. Okay. Jerry, so glad for you to join us. I'm glad I have another month to convince you. It's always good to see you here. All right. But anyways, yeah. Don't copy this down first. I'll explain all 4 boxes, then you copy everything down straight away. Okay. Moving on is basically the wavelength. By definition, it is the shortest distance between any 2 points in a wave that are in phase, right? For example, a longitudinal wave, it is the distance between 2 successive compressions or rarefaction. It is basically just compression to compression or rarefaction to rarefaction only, right? And the SI units are definitely in meters. Guys, pro tip, guys, anything in your syllabus, right, that has to measure length one, it doesn't matter if it's amplitude, wavelength, height, depth, whatever, anything that has to do with length, the standard SI units are always going to be in meters, guys. You have to know this, distance, displacement, all these are all measured in meters. You must know this. Okay, very important. Okay. Then, yeah, this part here is something I want to explain a little bit. Let's imagine today, right? Let's imagine today I have a wave. I have a few waves. Let's say this is a wave here. Okay. A few waves here. 1, 2, and 3. Assuming that they are all the same, by the way. It's just poor drawing by me. but let's assume that it is all in phase and they're all the same waves, right? Let's imagine the total time for these waves to complete was 9 seconds. Okay, today if I'm given the total time taken for this amount of oscillations to complete, I can find period. Guys, if you think about period, right, period is basically a measurement of time. You know, if I think the most closely resembled thing in real life is basically, it's a bit appropriate to say this, but the girls period, you know, it always come after a certain amount of time. There's a time frame for it to come on. In terms of physics, it will be the same thing as well. First thing you must remember is whenever we talk about period, right, it is a time frame, and because it is a certain time frame, right, it period is definitely measured in time, right, and time in your syllabus is definitely measured in seconds. First things first, you must remember is First things first, you must remember is period is measured in time and time is measured in seconds, okay? So from here, if I want to find out what's the period of this wave, first and foremost, I need to find out how many oscillations are there. Today, if I look at this example here, there's 1 oscillation, 2 oscillation, and 3 oscillations here. For 3 oscillations, I took a total of 9 seconds. Period is the measurement of how long one wave completed. You know, by definition, the period is the time taken for one wave to complete itself. Since there is 3 waves here and it took a total of 9 seconds, then the formula for period is basically the number of oscillations, the total time taken over the number of oscillations here. From here, if I want to find the period of this graph, right, the total time taken was 9 seconds, right? The number of oscillations were 3, right? You'll see that my period is actually going to be in 3 seconds here, meaning to say it took me a total of 3 seconds to complete 1 oscillation. So first things first, you must understand, period, the definition is the time taken to complete 1 oscillation. If it says that there's 3 oscillations completed in 9 seconds, to find the period, I'll need to find out how long it took for 1 oscillation to complete. Anyone unclear with what I've mentioned? Anyone confused with what I've mentioned so far? This is important because it builds up to the next part, which is frequency. If you're uncertain with this, it'll be a bit confusing, guys. Anyone unclear or not? Anyone don't know what I'm talking about? Good. 100% absorption rate from the 100% silence. Right, let's assume everyone understands this. From here, once we understand period, right, usually this period will be the one that leads up to frequency. Okay, frequency. By definition, guys, frequency is the number of oscillations completed in 1 second. Oh my God. Nice, whatever. Completed in 1 second. So guys, let's imagine today, right? If I have a wave that has 100 hertz versus another wave that has 200 hertz. You know what does the 100 hertz and the 200 tells me? The 100 hertz tells me that in 1 second, the wave completed 100 oscillations. So if I were to draw a time graph, right, it'll be like 100 of this. There'll be 100 of this, and it only took a total time of 1 second. If I have 200 hertz, obviously it's going to be more dense than the 100 one. It will be like something like this, right? Because it's double the amount, right? And these 200 oscillations only took a total time of 1 second. By definition, and this is important, guys, you need to know this. By definition, frequency is the amount of oscillations completed per second. And the formula for frequency is actually given as F equals to 1 over period. Okay, if today I want to find the frequency of this, right, it's basically F equals to 1 over 3, right, which gives me 0.33 hertz. 0.33 hertz tells me that in 1 second, this will be 1, this will be 2, and this will be 3, right? In 1 second, I can only complete 1/3 of the oscillation. That's why I only have 0.33 seconds. In 1 second here, in 1 second, I can only complete 1/3 of the oscillation. So So yeah, just in other words, you just need to know that frequency is the number of oscillations per second, guys. Very, very important. Oh, and obviously it is measured in hertz, guys. Hertz, 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 hertz. I'm pretty sure you've heard of this word before, but never really thought about it. Okay. Now, before I proceed on, anyone uncertain with whatever I've mentioned so far? Anyone wants me to repeat any specific part before I move on? Very important, I must know. Yes. Will they give like 3.5 numbers of oscillation in the graph? Yeah, possible. If it's a 3.5 graph, right? 3.5 oscillation, it looks something like this. With one oscillation, two oscillation, and the three oscillations and the other half here. It looks something like this. This will be a 3.5 oscillation, right? And if you ask to find the period, you need to find out how much here is first. Let's say, for example, I don't know, for ease of calculation, let's just say again, it's 10.5 seconds to complete 3.5, right? And from here, same application, you find the period, which is total time taken over number of oscillations, which is 10.5 divided by 3.5. Then you'll find out that your period is in 3 seconds. Then you want to find the frequency is yet again 1 over period, which is 1 over 3, which is yet again 0.33 hertz, right? Then you can find it, but usually they'll give you all the parameters except for one. So usually they'll only have one unknown in the question. It's just a matter of how you apply which formula to use only. Yeah, you understand what I'm talking about? Does that answer your question? Yeah. All right, good. If you have no questions, then yeah, looking at these statements here. Definition, this is time taken for 1 point of the wave to complete one oscillation. The SI unit is measured in time, guys. For some godforsaken reason, I always see the students mess this up. They'll tell me it's number of oscillations over the total time taken, which doesn't make sense, right? Guys, if you think about it, period is a time frame. Number of oscillations over time is 1 over second. That's not a time frame, that's frequency, right? So very important. Think before you apply your formulas, guys. It is total time taken over number of oscillations, right? And from here, frequency is the number of completed waves produced per second. The SI units are in hertz. The frequency is related to the pitch of the sound, guys. This is also a very, very, very important information, guys. The pitch of the sound is purely dependent on the frequency. Natalie here would have heard this before, but let me say this again. Guys, you know, like in general, men, right, are lazy creatures, right? If you think about it, all the time, all the conflict between men and women usually starts off with something like it starts off with something like it starts off something like, honey, what are you thinking about? And then the guy is like, I'm thinking about nothing. Right. And then the girls start thinking, like, why won't you tell me what you're thinking about? All those kind of scenarios, and they start getting into a fight, right? For some godforsaken reason, the girls don't believe it when we think about nothing. Is because in general, men, right, and your future boyfriends will all be lazy, right, and they will not think so much. So this is directly relatable to the frequency of your voice as well. In general, men are so lazy that their voice box have a relatively lower vibration frequency, right? And because we have a lower vibration frequency, our sound will be much deeper. If you have a super high tone, if you have a super high pitch, right, your frequency is vibrating very much. Right? Usually we say that the girls are more excited, like, with crazy girl fan girls scream, right? Yeah, oh my god, oh my god, oh my god. And this is because, right, their oscillation is crazy. If I were to put a number, maybe I don't know the exact number, but maybe women's voice box is oscillating at 1,000 hertz, right? Every second is 1,000 oscillations, but men will be at least half of it. Men will be like maybe only 500 hertz, right? So this is how you relate, guys. You're supposed to think that, oh, frequency relates to the pitch. because men are lazy, men have lower frequency and thus have a lower pitch. Women are relatively more excited, right? That's why their frequency relates, oscillates much more and generally talks much more in a higher pitch. That's how you remember, guys. All right. Yeah, this is very important. They always ask this in your IGCSEs. You actually need to know that frequency is related to the pitch. The higher the frequency, the higher the pitch, and amplitude is responsible for the loudness of the sound. The higher the amplitude, the louder the sound it is as well. Okay. All right, everyone. Anyone's got any questions with whatever I've mentioned so far? If you have no questions, please copy everything down before I throw. Oh, sorry. What's the difference? What's the difference of what? Between oscillation and period. Oscillation is how many complete cycles you complete, right? For example, a wave could have 2 oscillations. It means to say it completes 2 oscillations. Oh, sorry, 2 complete cycles. Let me write this down. Okay. So oscillation is the number of completed waves. Like for example, this one here is 1 oscillation. This one here is 2 oscillation. This one here is 3 oscillation. This is oscillation. Period is the time taken for it to complete 1 oscillation. Let's say, for example, if here the time is 1 second, right? Then the period of this wave will be 1 second because it only took 1 second to complete 1 wave. If let's say here is 1 second, right? That means to say the period is going to be 0.5 seconds because it took 0.5 seconds to complete 1 oscillation. Whereas if let's say this one here is 1 second, right? Then I know for a fact that the period here is 0.33 seconds because it took 0.33 seconds to complete 1 oscillation. You get what I mean, Lucas? Lucas, you understand what I'm talking about? Or you want me to repeat? Are you talking, by the way, Lucas? Your thing seems like it's lighting up, but you're muted, by the way. Oh, then do you understand what I'm talking about? Yeah. All right. Yeah, you can unmute yourself if you have a more complicated question. I think it's definitely the faster way to ask a question. But for some reason, all of you guys like to type. Okay. Yeah. Copy everything down, guys. Copy everything down. After that, we'll move to the final part if I throw you guys into some exercises. Kunling, I don't listen to your excuses. Okay, let me know when most of you guys are done copying. We'll go to the last part. Sleep again. No sleeping, bro. How was it, Jerry? Did you manage to do your questions? I'm pretty sure you'll have a change of heart. Ah, Why drop it? I tell you, you can score A and you just need a little bit more time only. Just do the exercises. Don't care about your school teacher. It's all you now. It's all you now, you know? 靠自己. Yeah. Prove to yourself you can do it. Then after that, when you score an A, you can go back to the teacher and you say, it's all me, buddy. It's all me. Okay, everyone, done. Yeah, chemistry is definitely hard. One of my least favorite subjects. Okay, then the final part here is basically talking about the speed of the wave. Now, by formula, guys, the speed of the wave is given as V equals to F lambda, guys. Guys, pay attention. For your speed of the wave, it is dependent on your frequency and your lambda. If today, right, you want a wave to travel faster, number one, you either have a higher frequency or you have a higher wave. Guys, by units, guys, the velocity of the wave is definitely going to be in meters per second. The units of a frequency is going to be in hertz, and the units of a wavelength is definitely going to be in meters. Now, some of my students, right, they'll ask me, hey, how come hertz multiplied by meters? Shouldn't it be hertz meters instead? Why is it meters per second? Now, the answer to that is simply because hertz is supposed to be a derived SI unit. Guys, if you think back about the formula for frequency, it's basically 1 over period, right? Which is supposed to be 1 over second, guys. It's actually supposed to be 1 over second, meaning to say, in reality, this is supposed to be 1 over seconds and this is meters. That's why ultimately 1 over second times meters is going to give you meters per second. And obviously, yeah, because it's velocity, right? So there's not going to be any other units to measure velocity besides meters per second. Okay. So this is the thing I want to talk about only. Everything else is quite standard. I think you should be able to attempt the questions at the bottom right now. Yes, Kunling, what is this YouTube video?
And now,
Kunling, have you been paying attention to whatever I've been saying? Have you been searching up for these YouTube videos instead? Kunling. Okay, but anyways, yeah. I hope so. I would hope so, Kunling. But anyways, yeah. This is the reason why, guys. Anyone's got any questions for this part here? Shut up. Oi, everyone can pay attention now. Oi, stop looking at the YouTube videos and whatever. Oi, pay attention. You understand or not? Everyone understand this or not? Yeah, I'm assuming everyone understands this. So if you can understand this, then copy this down. Everyone, copy this down. And then, guys, when you attempt the question, this is
ASAP side.
Oh my god! When you're done copying this and you're attempting the question below, this is how I want you to do it, guys. I think I've said this to you guys before. I can't remember, but I'll say it again, guys. These questions at the bottom here, right? They are designed to be easy. So why did I design it to be easy? Number one, definitely is because Wesley has already crushed your spirits, right? For those who are from Wesley here, namely Lucas, right? I don't want to do that. I want to let the students know that they can definitely do it. And number two is because I want you guys to be familiarized with the formulas, guys. When you're doing this question here, let's say, for example, I'm doing this question here right now. I'm going to identify and make it a habit to highlight all the useful information. Reading this question here, it says that a wavelength has a wavelength of 12 12 meters, right? I'll label this as my lambda. Calculate the wave speed. I'm looking for the speed if it has a frequency of 20 hertz. Once I've identified all this information, I'm going to write my general formula for speed, which I'm going to say V equals to F lambda. Say it in your head a few times. When you go to exam, you'll be surprised that, oh shit, I can actually recall this formula, right? Then you're going to write down everything accordingly. It's going to be 20 multiplied by 12, and you're going to get 240 meters per second, guys. This is how you're supposed to attempt the question, guys. V equals F lambda, V equals F lambda, V equals F lambda. Say it enough times, write it enough times. For every question here, you'll be surprised. You will be pretty damn surprised that you can actually recall it in your exam. So everyone, do it according to this format. I'll give you guys 10 minutes to attempt the questions right now. Then after that, we'll discuss the answers. Everyone should do all the way until question 4. Everyone's please start doing it right now. Kunling, how can you still not know how the equations work? Lambda equals to F over V, bro. Lambda equals to F over V, even though it's like this here. You know, I'm too tired. I don't want to hear excuses. I only want plays, Kunling. Don't keep chit-chatting only, but make sure you guys start doing the questions. What the hell? Lambda F over V. What? Bro. Are you insane, bro? Bro, looking at this formula here, if let's say I say that V is equals to F lambda, it's like equivalent to saying 8 is equals to 4 times 2. Bro, if you say that it's F over V, right, you're basically saying like 4 is equals to 2 over 8, that kind of scenario, you know? Bro. You know, you, you know how algebra works, right? If you want to find the f, is this one to the bottom, so is this one to the bottom. V over lambda equals to f, whereas 8 divided by 2 is equals to 4. Bro, are you okay, Kunling? Ah, faster do. For some reason, my iPad is not sharing. Give me a minute, guys. I hope you're all done, by the way. Okay, guys, if you are all done, which hopefully all of you guys are, can you check your answers? The first one here, you're supposed to get 240 meters per second. Second one, you're supposed to get 5 meters. Third question, you're supposed to get 5 seconds. And fourth question, you're supposed to get 0.5 hertz, right? And moving on, question 5 is 20 hertz. Question 6, you can ignore it because I don't know what I was typing. But question 7, you're supposed to get 10 meters. And finally, question 8, you're supposed to get 0.04 meters per second. Yeah, guys. Anyone's got any questions, or anyone couldn't handle any question they would like me to discuss a little bit? Yeah, I'm assuming everyone got everything correct. If this is the case, yeah, then yeah, I'm just gonna go through one more quick thing before we end the day. We'll leave the rest for next week, guys. You know, like how I've mentioned just now. Oh, sorry, there was. Oh, sorry, I didn't see the text. This is why lah. You should always just unmute. Question 6, not 1. Oh, yeah, just ignore question 6, guys. I think I don't know what I was typing, so you know. But anyways, ignore it. Okay, yeah, last thing before we end the day, guys. You know how I mentioned just now that there are only 2 types of wave, right? Which is either the transverse wave, which everyone knows by now, and also the longitudinal wave, which everyone knows by now as well, lah, right? Now, in your IGCSEs, sometimes they may ask you to define a transverse wave and define a longitudinal wave in terms of its vibration and also propagation, okay? Let's imagine today I only focus on one specific particle here, okay? I'm specifically focusing on one particle here. Without it moving because it's a transverse wave, right? It's going up and down, right? Without it moving, it will actually just go up, down, up, down, up, down. It will vibrate up and down, up and down, up and down, up and down. This is the behavior of a transverse wave. But once this wave starts moving, it will still go up and down, but it will be propagated towards the right. It will go up, down, up, down, up, down, up, down. So from here, you should understand that in terms of vibration, a transverse wave's vibration is perpendicular to the propagation of the wave. For those who cannot remember the word propagation, you could say it is direction of travel is acceptable as well. Direction of travel. Okay, if you write that a transverse wave has vibration perpendicular to the direction of travel of the wave, that is the acceptable definition as well. Whereas for a longitudinal wave, guys, the vibration will be parallel to its propagation. Yet again, without propagation, the wave here, the particle just vibrates left, right, 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 right. With the propagation, it will still vibrate left and right, but it will be propagated towards the right. So it's going to be a left, right, 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 and so on. Okay, so this is how you define a transverse and longitudinal wave. You don't have to write this down as well as in the notes, but I just wanted to give you like a opener for next week's class. Okay. Yeah, guys, I think I'm going to stop here today. If you have any questions, you're more than welcome to stay back and ask me anything. But if not, as usual, that'll be it for today, guys. I'll see you all next week. Oh, welcome. Goodbye. Hey, Lucas. Can you stay for like probably 2 minutes? I'd like to talk to you a little bit. Yeah. Can you unmute yourself? Everyone's
Yeah, sir.
hey man.